Hi, well we've got another bit of obscure and doubtless very expensive kit to take a look at today. This is a Aerometrics phase Doppler particle analyser. It's about 2 feet long, very heavy, it's about 15 kilos or so, and it's just got a real feel of just expensive solidness, precision machining, and highly specialised, very obscure kit. Now on the back here we've got 3 BNCs, a multi-pin connector, and this thing marked Cal, which actually looks like it's some sort of optical connector. We've got some precisions, sort of alignment things on this ring to adjust it, and there's this sort of covered port which I'm assuming is for some sort of alignment or calibration type thing, and this great big lens on the front. On the label it says manufacturing date October 1998, and it also says conforms to 21 CFR 1040, which is regulations concerning lasers, but there isn't a laser warning sticker on this. I suspect there is a laser as part of the system, but it probably isn't inside. I think this is probably just the detector part of it, and I'm sure there'll be a big sort of pile of gear that these connectors plug into that forms the complete system. I had to hunt around a bit to find some information on this. So basically what this is, it's for measuring the speed and size of particles, typically things like liquid sprays, and as far as I can tell it works out, most of the drawings I've seen show separate detectors and lasers, so it looks like we've just got the detector here, so there's sort of a couple of laser beams, and it produces a volume which has got two beams which produce interference patterns, and then when particles pass through that, it sort of reflects those interference patterns into the detector. It can then analyse and figure out information about the size and speed of those particles. So I suspect basically what we've got in here is probably 3 photomultipliers and some sort of funky optical stuff. Came with this sort of big lens cap on the front. It's a nice sort of big lens cover. This one just on screen, this just feels quality, just sort of precision machining, just extremely smooth, very fine thread on this. Let's hold this in, and then this lens, it's actually being slowed down. It's such a sort of close fit that the actual air, it takes effort just to pull it out because of the limited air that can get through this precision gap. So this is really heavy. This has got to be at least 1 kilo of lens. I think it's a single element, so it's probably about 1 inch thick or so. And there's another lens in here. I think this is, so it's either one very thick, like 1.5 inch thick lens, or 2 lenses. Not totally sure. This is made by Melez Griot, who specialise in basically everything to do with lasers, optics, lasers, all sorts of stuff like that. And if we take a look inside, there's not a lot that we can see here. There's these 2 squares are the back of the those inspection covers which are on the side. I'm not sure if these are different or there's just one each side, so you can use whichever's most convenient. There seems to be a thing in there with, I think it's got a small slit. There's some sort of target or something. I think there's a very small slit in there, and there's a number, so I presume this is an interchangeable part for doing different performance or something. So looks like we're going to have to look in the other end to see what else is in there. Right, let's take a look at this back end. Allen screws here. I think there must be some rule book somewhere that says all expensive equipment must use Allen screws instead of normal screws. Don't quite know what that's about, but it does always seem to be the case. And these 3 BNCs, I'm sure, will be the outputs of the 3 photomultipliers or whatever other detectors there are in there. I can't see that much yet. We've got the BNCs connect to the back. Seems a little excessive. And there's 3 wires going to this connector. I think these are actually fibre. Yeah, it says fibre optic cable here, so these are going to these wires are going to some sort of fibre port, so I'm guessing if this is a detector, this is maybe where you can sort of shine some calibration light in there to get some light into the sensors at a known level to calibrate it. And there's this secondary connector that connects into this multi-pin connector here, so obviously no expense spared on this thing. So that connector there just mates with this back one that's on a PCB that seems to just connect into this middle one. I doubt there's actually any components at all on that PCB. Actually there's a couple of voltage regulators on here, but nothing too exciting. It's just a 7812 and a 7912, so that's a plus minus 12 volt local regulation. And this looks like a fibre connector onto the back of this. Yeah, this is a fairly standard looking fibre connector. I'm assuming they've just terminated 3 cores into it to presumably get light out into each of the 3 detectors. Because I know that's a thick cable. The actual fibre in there is probably going to be like a hair thin single strand cable. Get that back ring on, and we can see 3, so I'm sure these are almost certainly be photomultipliers. These calibration things seem to go into this block at different angles. Actually, they're just held in with little Allen screws. Yeah, so these are just terminated fibre ends going in, yeah, one pointing to it towards each detector, so I'm sure that'll just be to enable some light to be shone in for calibration and testing. So let's see how we can get further into this. Yeah, so it looks like these are side viewed photomultipliers sort of pointing into this central optical block. I'm guessing it's probably just unplug. Yeah, so these look like fairly standard R928 by Hamamatsu. 1990 date code. And it looks like there's a sort of prism or something on the edge. These are in cans. These will be for magnetic shielding, because these things are quite sensitive to magnetic fields. I'm guessing there's probably not much in the way of electronics. I think there's probably going to be just the power supplies to the photomultipliers, possibly a preamp. I can't really see that there's going to be much else, unless there's maybe some motors to actuate some optical bits to select different modes. So we have a little sub-assembly. That's that little thing on the front. So that's just an empty tube. Yeah, on the this little front bit there's a very, very tiny little slot in there. You can probably just be able to see. And this is feels like a fairly thin sort of aluminium can. So let's take this off. That's interesting. Oh, actually, I wonder if... Oh, see, yeah, these are basically the back ends of the photomultiplier. So this is going to be an integrated high voltage supply, divider, and maybe a preamp as well in here. So yeah, all this is really is 3 photomultipliers and an optical block. And there's a position for a 4th one here. There's a spare connector position on the back as well. That's not being populated in this one. There's four wires going into this, so what I'm guessing is we had those plus minus supplies from the voltage regulator. There'll be a ground as well. It looks like there's an extra lead here, so I'm guessing that probably these two are sort of plus and minus. They look like they're going through feed-through capacitors. I wonder if that could be the DC into the high voltage supply. Quite often the way these work is the output voltage is scaled according to the input voltage. They actually use the input voltage as a reference in a closed loop feedback on the output, so that the output is linearly proportional to the input voltage. So my guess is what we've got here is ground plus positive negative supplies and a power supply plus voltage select, and also you've got the coax output. This is feels like PTFE coax, and then obviously the tube plugs in the other end. Surprisingly, there isn't a separate photomultiplier supply, so I can only imagine that they're actually running these at a fairly low voltage. Because I mean, that tube is rated at 1250 volts anode voltage, but obviously there's heat shrink, but there's no. But yeah, they've used a bigger feed through. But I mean, they're using sort of standard thickness wire. There's no particularly obvious additional clearance on the PCB. They haven't sort of put unused pins or anything, apart from just running the tracks on the opposite side of the board. They don't really seem to be putting any, I would imagine that something this expensive, if it was using 1250 volts, I'd really hope that they'd improve the track spacing and insulation a little bit, so perhaps they're actually running these at lower voltage than normal. And so in the back you've got, this is the fairly standard photomultiplier base, which has got a resistive divider chain that provides all the intermediate voltages to the diodes, and then this is a CLC 401, which is a high bandwidth op amp. So this is obviously working at fairly high frequency, providing sort of the front end amplifications. A couple of diodes there, which I'm sure are just protection against flashovers or high voltage from the tube. The 7805, 7905 regulators to provide a local power supply, and that's it really. So it's a fairly simple sort of photomultiplier plus amplifier assembly. Let's take a look at the rest of these optics. Inside the back of here, so we've got this tiny little slit on the front, and there's a lens on the back. So I'm guessing sort of this is designed to focus on a very specific area at a specific distance, and the slot just sort of takes a small section for where you actually want to do the sampling, and then that lens feeds the light down into this optical block. And this looks like it's got some filters in it. If we just sort of shine some light in it, we can see some nice sort of green. Now that I'm sure that'll be 532 nanometers for use with a sort of standard DPSS green laser. So it looks like there's a filter and then some sort of reflectors that move it out sideways. Interesting, although there's 3 photomultipliers, only looks like there's 2. There's one exit there. Oh, actually, I think maybe this one fires in 2 directions. Yeah. So it's bouncing into 2 different ways. So we've got one exit there, one there, another one there. Yeah, so nothing particularly exciting in here. We've got this was what's holding this filter. I don't know if this horizontal piece is optical or just for mechanical support. and this, I'm guessing, is probably a narrowband sort of green filter. This sort of quite narrowband green filter. On the edge it says 5145-10 0 degree T-BDF. No idea what that means. And then this prism block. This is just 3 prisms that sort of take the light coming from the front and just bounce it in into the sort of 3 different directions for each of those multipliers. So nothing very exciting. Well, I must say that was a bit of a disappointment really. It was just really a big funky box with 3 photomultipliers in it. I was sort of half expecting to have a laser or something in there, but that's the gamble you take when you buy this unknown crap off of eBay. But I'll probably stick the photomultipliers on eBay at some point, and say the scrap aluminium value is probably going to be fairly close to what I paid for it. Not sure if those lenses are going to be very interesting for anything. I'll have a quick play with those, but no. Hopefully the next bit of weird stuff will be a bit more interesting than this.